And contents for today's lecture are definition of database, types of databases, limitations of flat file databases, relational databases, and different types of keys. First of all, the definition of database. What is a database? Database is a collection of logically related data. A database program is a software which is responsible of storing and retrieving data in a structured way. This includes the data that is stored in a database and the links between the data items. All databases stores data using a system of files, records, and fields. As database is an electronic file cabinet in which data is stored in an organized way, in a structured way. Data stored in database is logically related with different types of links. These links are called relationships between data items. And a database program or a system is a computerized record keeping system. And this system is responsible for overall performance and maintaining the data, storing the data, and retrieving the data whenever data is needed. A database is a collection of logically related data, so the data is gathered and maintained for use by an organization. An organization using databases can be a single person or it can be a large organization having number of employees. Different types of organizations that uses databases are banks, hospitals, universities, different private companies, government departments. Operations performed in data stored in databases are adding a new files to existing database, inserting new data into existing files, retrieving data from existing files, updating data in existing files, deleting data from existing files, and removing existing files from the database. These are the different type of operations that can be performed on a data stored in a databases. As data in a databases are stored in the form of rows and columns, and the intersection of rows and columns is called a cell. And a cell contains a data item, a single piece of data. Rows are called records and columns are called fields. A field is a single item of data. Each field has a field name used to identify it within the database, and it has a specified data type according to its data stored in the particular field. Record is a collection of fields represent the information of one person or one item stored in a table with the help of different types of fields. So a record is a combination of different types of data. It has different data types according to the number of fields. And file is an organized collection of records, usually where all the records are organized so that they can be stored together, and a file have one or more tables within it. And the file is called a database, or a combination of files is also called a database. Different types of databases are flat file databases and relational databases. A flat file database stores its data in one table. Organized data in the form of rows and columns. Columns shows fields, rows shows records, and intersection of rows and columns shows a cell, and cell contains the data item. Predefined data types is used to store data in a column. It depends upon the type of field. Relational databases. A relational database stores data in more than one linked table, and that table is called a relation in a relation database, and this table stores data in a file. Relational databases control the redundancy of data, means same data is not stored many times with the help of a key, and that key field is called a primary key. Each table in relation databases must have a key field, and that key field is a primary key and the properties of key fields are it must contain a data and it cannot be a null. Suppose, or for example, you are going to store the students data and the teachers data in a traditional file system, that is a flat file database. It looks like this. There are different types of problems. There are different types of limitations for this. Data integrity is not maintained. Redundancy of data is not maintained here. Privacy issues, inconsistency issues, data duplication, data dependency. These all are the problems that are in the traditional file system. These all problems can be resolved by splitting the table into two. In this scenario, in teachers table and in students table, the information of all the teachers are stored in the teachers table and the information of all the students are stored in the students table. For this, and a link is maintained with the help of relationship, and the type of link or relationship type is one-to-many for this criteria. In this way, you can retrieve the data or store the data for the students or teachers linked with each other. Limitations of flat file databases or traditional file systems are: the first is data dependency concern. In the traditional file systems, the physical structure and storage of data files records are defined in the application programs. Any change in the structure of a data file required changes in the entire application of the program. This makes change in the structure of the data file difficult. This characteristics of file-based or traditional file system is known as program data dependence, or sometimes it is also called interdependence of data and program. The main objective of database approach is to overcome this type of problem. The database approach provides data independence. It allows changes in data structure without changing in the application program. It makes data independent of the application program. It also allows programs to be modified without reorganization of the data. In this way, the data is not dependent on the application programs in the modern scenarios of databases, whereas in the traditional file system, the data and the application program both are dependent on each other. The second limitation of traditional file systems or flat file databases are data integrity. In the file-based systems, same data items is usually stored in more than one file. This is the duplication of the data. For example, employee's home address is saved in two different files in traditional file system, and it is stored in accounts file. It is the first type of file, and the second type of file is administration file. Suppose the employee wants to change his residence and the new address is updated onto the administration file and it is not updated in accounts file. Now suppose for example, the accounts file has the old address and the employee's paycheck will be sent to the wrong address. This is another limitation of the flat file or traditional file system, which is overcome by the databases. In database approach, each data item is stored as far as possible at one place only, and this is not only saves time and storage requirement, but it also maintains the data integrity. And third limitation for a flat file databases or traditional file databases are traditional file systems are data redundancy. In flat file databases, as there is no key field, so a repeated data or duplication of data can be in flat file databases or traditional file systems. Whereas in relational databases, a key field is required field for every table or every relation. So in relation databases, there is no data redundancy, there is no duplication of data. In this way, data integrity or entity integrity is maintained with the help of a key field. And fourth limitation of flat file databases are data integration. In a flat file or a file-based system, data is stored in a separate and independent files. It is more difficult to access data from different files stored at different location. That is called isolated files. And an objective of database approach is to solve this type of difficulty. In databases, the information is logically centralized. This means that data may be stored on different computers in a network as different files, but it is logically appeared as a one file. In this way, the data can be accessed within a no time. Now, what is relational databases? A relational database stores data in more than one linked table, and the tables in relational databases are called relations. So a relation database stores data in more than one linked table and stored in a file. In a relation databases, a special type of table is used to store the data in a database, and that special type of table is called a relation. Columns in or fields in a relational databases are called attributes, and row or record in a relation databases is called a tuple. How tables or relations are created in relation databases? First of all, a name is given to the table or a relation in a capital letters, and then attributes are named, and more than one attributes are separated by a comma within a parenthesis. In a database design, a table would be given a name within attributes names listed in brackets after the table name, and all the attributes are separated by comma. For example, these are the two definitions of two tables: student table and a teacher's table. Student ID, student first name, student second name, English, maths and science, these are the attributes for the student table. And teacher ID, forename, surname, subject and room are the attributes for the teacher's table. And student and teacher in capital letters are the names for the relation. A logical view of data stored in these relations are: in teacher's table, 5 columns are required as 5 attributes are there, and in student's table 6 columns are required to create a table as 6 attributes are there, and teacher's ID and student ID are the key fields that uniquely identify the data within both the tables, teacher's table and student table, and there is no duplication of data as redundancy of data is controlled with the help of key field. Properties of a relation in a relational databases. The first property is there can be no duplicate rows. A relation must have a column that contains a unique value for each row. This column is called the key field of a relation, and the values in the column are used to locate a row in a relation. If there are duplicate rows, there cannot be any key in the relation. In this way, the redundancy of data is not controlled. Redundancy of data is controlled only when the key field is defined for the particular relation. So in relation databases, every table, every relation must have a primary key or a key field that controls the redundancy of data. The second property is the order of the rows is insignificant. A row is located by its key. It is not identified by the position in the relation. So It may be located anywhere in the relation. Its position is insignificant. There is no particular order to write the attributes or to write the data for the particular columns or fields. The order for the columns is also insignificant. A column is located by its field name. It is not identified by its position. So, column can be located with the help of its name. So, it can be anywhere in the relation and its position is not significant. Its position doesn't matter. Fourth property is each cell of table contains atomic value. Atomic value means a single value. A single value that cannot be further divided is called atomic value. All intersection of columns and rows contains an atomic value. It means a data item must be an atomic value. It can be a single value. It cannot be further divided. If there are two or more values, then these cannot be located by the key of the relation. So it is a property of the key field. The key field only locates, only accesses or retrieves the data that is atomic. What is a key in a database? A key is a single attribute or a set of attributes which is used to uniquely locate a record in a relation. Some important reasons for using keys are: a key ensures that each record in a relation is uniquely identified. Keys are used to establish relationship among relations. Keys are used to establish and enforce data integrity. Data integrities are further divided into two types: entity integrity, that is maintained or ensured with the help of a primary key, and referential integrity, that type of integrity is ensured with the help of foreign key. Different types of keys are primary key, candidate key, secondary key, and foreign key. The first key is a primary key. The primary key is an attribute or a set of attributes that uniquely identify a row in a relation. It means a primary key can be a combination of attributes or it can be a single attribute, and the purpose of primary key is to uniquely identify a row in a relation, in a table. Every table or every relation in a relation database must have a primary key. Entity integrity is ensured by the primary key, and this entity integrity controls the duplication of data as well. Properties of primary key are: it must not have a null value, its value must be unique, and the value stored in a primary key must be atomic. In these two tables, employee table, there are three fields, three attributes: employee ID, employee name, and employee date of birth. And the primary key for this table is employee ID. This primary key consists of a single attribute, and primary key can be a set of attributes. For the work table, employee ID and project ID, both attributes are the primary keys. So it is a combination of different fields. Set of attributes are used to uniquely identify the data in a works table. So this type of primary key is called composite primary key or concatenate primary key, as set of attributes are used to uniquely identify a row in a relation work. The second type of primary key is a key is candidate key and secondary key. Sometimes a relation has one or more attributes that can be used as a primary key. An attribute or a set of attributes that could be chosen as a primary key is called a candidate key. As there are more attributes that can be used as a primary key, only one is selected. A candidate keys that are not chosen as a primary key are referred to as a secondary key or alternate key. In this example, in this relation, employees relation, employee ID, employee CNIC, employee name and employee date of birth. Only two attributes are there. They can be uniquely identified. The other fields, other attributes and the candidate keys in this relation are employee ID and employee CNIC. Chosen primary key is employee ID. So employee ID is a primary key, and the second it can be a second priority or it can be a second attribute that can be used as a primary key but cannot used. So the left candidate keys are called alternate keys and secondary keys. So employee CNIC number is a candidate key or a secondary key. Foreign key. A foreign key is an attribute in a one relation that refers to the primary key in another relation. This key is used to create a relationship between the tables. A relation that contains a primary key is called a parent relation, and the relation that contains a foreign key is called a dependent relation. And referential integrity is ensured by the foreign key, as there are two tables, employee table, employee relation and work relation. In employee relation, employee ID is a primary key, and in work relation, employee ID exists as a foreign key, and this foreign key refers to the data stored in a primary key. It only accepts that type of data that is stored in a primary key of the employees relation. So employee relation contains a primary key, so this relation is a parent relation, and work relation contains a foreign key, employee ID as a foreign key, so this relation is a dependent relation. It means that only the data that exists in a parent table is allowed to stored in the foreign key of dependent relation.